Hey guys, welcome back to my channel. And in today's video, we'll be talking about a topic in data structure, which is stacks. Without wasting any time, let's get started. Firstly, what is data structure? As the name says, data structures, it is the structural format of storing, processing, retrieving the data. This data structure is divided into two parts, which is linear data structures and non-linear data structures. Under linear data structure, we have arrays, queues, stacks, and even others like linked lists. Meanwhile, in the non-linear, we have trees and graphs. Now, learn more about linear data structures. As the name says, linear data structure is the format where the data is arranged in linear sequence. As you can see in this diagram, how the data is structured in a linear format. It includes arrays, stacks, queues, linked lists, etc. The data items can be traversed in a single run. And in linear data structure, elements are accessed or placed in contiguous memory location, which means that they are placed together in a sequence. Even in non-data structure, as you can see, the data is not stored in that way. It is divided into different parts. That's why the trees and graphs are the examples. Let's see what is a stack. A stack is called as a last in first out collection. What is last in first out collection? In the last in first out collection, the last thing we add, which is when we push an item, is the first thing that get popped out, which get pulled, which means popped out. Let's say we're keeping a book in a sequence and we need to access a second book in a row. Let's see a diagram to know it in a better way. Let's say we have a pile of books and we want to access this third book. To access this, we need to remove the upper ones, which means that they were added at the last. So that was the last in first out says. Stack is a sequence of items that are accessible at only one end of the sequence. You can take a pile of books or even plates as an example, or the CD drives. Now let's see the operations that can be performed on stacks. The main two operations which are performed in stack are push and pop, and the rest are top, is full, and is empty. Now let's see what are these operations, what are their functionalities, how they work. Push is used to insert the items in the stack. As you can see in the diagram, we use the push operation to insert an element 1 in the stack. Again, we use the push operation to insert element 2, again the 3. As you can see, we are using the last in first out operation, which is the one we enter last is at the top. And to take them out, we use the pop operation, which is it is used to delete the items from the stack. Basically, to remove an item or delete the item, use this pop operation. The top represents the current location of data in the stack. If the top is 0, which means that we are inserting something in the stack. Normally, if an stack is empty, the top will be -1. The is empty and is full operations are used to check whether the stack is full or is empty. The algorithm of insertion in stack, which is push, to check if the stack is full. The stack, if the stack is not full, then we increment the top pointer. As you can see, we are incrementing the stack. Then later, we place the new element at the position pointed by the top pointer. Later, we update the value at the top position with a new element. As you can see, we are adding a new element 10 here. This is the code format of the push operation. Here we have used the if condition. Now let's move on to the next line. Here is the algorithm for the pop operation. First, we check whether the stack is empty or not. And if the stack is not empty, we retrieve the element at the top of the stack. Then we decrement the top pointer to the next element in the stack. Here is an easy example of a pop operation. Here you can see we have used this to decrement the top pointer. Now let's see how we display the stack. The algorithm for displaying the elements of a stack is typically involved iterating through the elements from bottom to the top without modifying the stack itself. To display the elements, we iterate throughout to the stack from bottom to the top. The code we use is here. Here we use the if condition, and then in the else we have used the for loop to to display the elements. Application of stacks are: first, we use it to reverse the strings. It is a simple application for a stack. To reverse a string, the characters of string are pushed on the stack one by one as the string is read from the left to right. Once all the characters of the string are pushed onto the stack, they're popped one by one. Since the character large pose is coming out first, subsequently the pop operation results in reversal of the string. Let's see in a diagrammatic way. Here, as you can see, how we have used the push operation, reversing a string. Then later, after pushing the elements, we have popped out the elements too to reverse the string. Let's see another example, which is checking the validity of an expression containing nested parentheses. Stack is also used to check whether a given arithmetic expression containing nested parentheses is properly parenthesized. The program for checking the validity of an expression verifies that for each left parenthesis bracket or bracket, there is a corresponding closing symbol and symbols are appropriately nested. Let's see how this actually works. Here I have given two inputs. Here are the valid inputs and invalid inputs. We always need to add the parentheses of the brackets properly to have a proper valid output. And here we use the stacks. Now, third, where we use the stack is to evaluate arithmetic expression. The three popular to evaluating them are infix notation, prefix notation, and postfix notation. The general way of writing an arithmetic expression is known as infix notation. As you can see, we have given an example over here where we have used the operands and operators. A and B are the operands and plus sign is the operator. In the prefix notation, first the operator comes and later the operands. Meanwhile, in the postfix notation, first the operands comes and later the operators. Let's see more example of this. We use stacks to convert this infix to postfix conversion. Let's see how this works in stack. As you can see, we push the elements first and later we use the operators to calculate them. It depends on the operators on which on which operands it's going to be used on. As you can see how we are converting it. First, we push the brackets and then the plus operator. Then we add the two operands and later in that way, using the push and pop operation, we get the postfix notation through infix. You can pause the video and see how it works. Thank you for watching.